Hello students, today we are going to start from exercise 8.2. As you know, we have finished all the questions of exercise 8.1. So let us start first of all the fundamentals of 8.2, then we shall proceed to the question. So here we are going to learn a very important topic that is known as midpoint theorem. Midpoint theorem is very important topic in concern of class 10 as well as class 9. Class 9, you will get plenty of questions on midpoint theorem, not only in this chapter, but in some other chapter also. For example, next year you will study coordinate geometry. In that also you will use the midpoint theorem. Okay, so here, first of all, we shall see what exactly a midpoint theorem says, because now we shall deal a question mainly on this theorem only. This theorem is divided into two parts. One is the main part, which is called as the midpoint theorem, and second one is called as the converse of midpoint theorem, means it is an opposite part of midpoint theorem. Okay, so let us see the first of all the main midpoint theorem. The line segment joining the midpoint of two sides of a triangle is parallel to the third side, and here one thing is missing that I will write down now only, and equal to half of it. Okay, this is actually a theorem. So that line was missing over there, so that I have written here. So see, this is our theorem. The line segment joining the midpoints of two sides of a triangle sorry, is parallel to the third side and equal to half of it. Now what this theorem says, if we read this statement 2 times, 3 times and 5 times also, then also things are not very clear. I will give you an example. With the help of that, easily you will understand what exactly a midpoint theorem says. Okay, midpoint theorem is easy to understand. Converse of midpoint theorem is bit difficult to understand. But don't worry, we will revise it 2-3 times, then it will stick in your mind what exactly the converse of midpoint theorem says. Okay, first of all, see what they are saying. The line segment joining the midpoint of two sides. Suppose we are taking two sides of a triangle. I am taking side AB and side AC. Okay, they are saying take two sides. So we have taken two sides AB and AC. Now on these two sides we will have the midpoint. Okay, so suppose I say E is the midpoint of AB and F is the midpoint of AC. Now E is the midpoint of AB means the length of AE and the length of BE will be equal. Okay, same way the length of AF and the length of CF will be also equal. Okay, so these two midpoints we have given. So first of all we shall mention the given things here. What exactly are given we should have to apply the midpoint theorem. Given required, I will write down clearly here, given required to apply midpoint theorem. Okay, so what given required? In triangle ABC we required E and F are midpoints of E and F are midpoints of sides AB and AC respectively. Sides AB and AC respectively. Okay, so this is the required given. You cannot apply midpoint theorem on any triangle. Okay, you required this given first. If you have this particular given, you can apply the midpoint theorem. Okay, now see, if you have this given, then what will be the result in that case? So now I will write down the result. In that case, I will write down clearly here, if you have above given things, okay, if you have these things are given, then we can say that, see, the line EF you are observing. Okay, EF will be parallel to the third side. Who will be the third side here? See, two sides already we have taken as a midpoint over there. Okay, so we can say that the third side which we have not taken up till now, or whose midpoint we have not taken, that is called the third side. So EF and BC will be always parallel. EF is parallel to BC. Okay, similarly, I can say that EF will be half of the third side that we have written equal to half of it. So EF will be always half of the base BC. Okay, so here two things, remember, we should have E and F should be the midpoint of two sides over here. When you will join that two midpoints, it will form a line, and that line will be parallel to the third side and equal to half of it. Means that line joining the midpoint will be half of the third side. EF will be half of BC. Okay, this is your theorem. Converse of midpoint theorem, I think I should not explain you right now. We can do it little later. We shall deal one or two questions on the midpoint theorem. Then I will come back to the converse of midpoint theorem and I will explain. Because both the theorems, if I explain you together, it will confuse you a lot. Okay. So first of all, you should stick in your mind one thing. What is a midpoint theorem? Once again, I repeat, midpoint theorem, you require two midpoints on the two sides of a triangle. When you join the midpoint, the line joining the midpoint is always parallel to the third side of triangle and it will be half of it. Okay, means the EF will be parallel to BC and EF is equal to half of BC, provided E and F are the midpoint of side, side AB and AC. Okay, so I hope now this theorem is clear to you. As I told you just now that we should do the converse of midpoint theorem little later. Okay, actual questions of converse of midpoint theorem will come from question number 4 onwards, I suppose. So first three questions we should not worry it at all, that the questions are coming of both of them. So we will start first question, second question, and then when actual question number fourth will come of depending on converse of midpoint theorem, on that time we will do it this particular theorem. Okay, so let us see the question number 1 now. First question, see the first question what they are saying to us. In the first question they are saying ABCD is a quadrilateral in which P, Q, R and S are midpoints of the sides AB, BC, CD and DM. See figure. Okay, look at the one quadrilateral is given to us and P, Q, R and S are given the midpoint of the respective side. AC is one of the diagonal is given. However, we can draw the another diagonal, but since it is not required part of the question, so we have not drawn it. Now we have to show that three things. SR is parallel to AC. SR is half of AC. Are you looking the side SR over there? So SR we have to show it will be parallel to AC and SR will be equal to AC as well. Then second part we have to show PQ and SR are equal, and finally we have to show PQRS is a parallelogram. Remember, if you want to prove a parallelogram, then we can prove it by 2 to 3 ways. The one way is we can show that their opposite sides are equal. So PQ and SR are equal, PS and QR are equal. Or we can show the opposite sides are parallel. So PQ is parallel to SR, PS is parallel to QR. Or we can show that any one pair of opposite side is equal as well as parallel. Means PQ is parallel to SR, PQ is equal to SR. So we shall see that things in the part number third, which way can be applicable here. First of all, I will write down here the given things. So in the given what we have given here, ABCD is a quadrilateral. So we shall write down in a quadrilateral ABCD P, Q, R and S. P, Q, R and S are midpoints of are midpoints of respective side. That is, with the help of figure it is clear that they are midpoints of which sides. So we can write down simply here respective sides. Okay. Now we shall mention to prove. So to prove we need to mention as it is. There is no change. First part, SR is parallel to AC and SR is equal to half of AC. That is the first part. Second part we have to show here, PQ is equal to SR. Okay. And third part, what we need to show here? Third part we need to show here, PQRS is a parallelogram. Okay. Now let us start the proof. So first of all, in the proof, I will draw one figure to convey you in a proper manner what exactly I am going to take here. Okay. So first we shall draw one triangle. Here we are not going to prove the two triangles congruent. It is over now. Okay. Now that fundamental we may use only in one or two questions of 8.2. I think mainly we shall use in the question number 7 only. Rest of the question we will not use the fundamental of congruent triangles. Okay. Suppose this is one triangle is taken and one line also I will draw it here. Let me draw the line first. Okay. Little bit will shift here. Yes, perfect. Suppose now see the name of triangle what I'm taking here. As you can see the main figure, look at the main figure. You will observe many triangles are there. Okay, there are plenty of triangles are available in the given figure, but I am taking the triangle ACD. Are you looking at the triangle ACD? And in that S and R are the two midpoints are given to me. S it will be a midpoint of AD while R will be a midpoint of CD. Okay, so here this point I am taking as D, this point I am taking as A, and this I am taking as C. And as you know, S is a midpoint of AD and R is a midpoint of CD. Once again check, S I mark as midpoint of AD, right? And R is a midpoint of CD. Look at the main figure. Now see this triangle I have. Now try to remember in the midpoint theorem what I have told you. See, S is a midpoint of AD and R is a midpoint of CD that is given to us. So if you join the line SR, line joining the midpoint is always parallel to the third side and it will be half of the third side. So see, first part got over. SR is parallel to AC and SR is equal to half of AC. That is over now. Okay. So see how we can write down these things. We will write down in triangle DAC. This triangle you need not to draw again. I mean that it is not a part of the solution. This triangle I have drawn only for your information. Okay. So in triangle DAC, I will write down S comma R are the midpoints of sides AD and CD respectively. Okay. Now we can write down therefore by midpoint theorem. By midpoint theorem. Now by midpoint theorem what we can say here? You know it now very well. By midpoint theorem we can say that SR, the line joining the midpoint, will be parallel to the third side. Who is third side here? AC. And it will be half of the third side as well. So SR will be equal to half of AC. Okay, so here you can see that proved first part. Okay, first part got over. Now what we need here? What is second part required? PQ and SR we require to prove equal. Now see how we can show that PQ and SR are equal. Before we prove PQ and SR are equal, one thing you observe, if I take a triangle ABC, okay, ABC if I take, so P and Q are the midpoint. Now see again and again we are not doing the same thing over here. Okay. So one thing, these things you have to see it orally. Look at the triangle carefully. A, B, C. Right. In this triangle, P and Q are the midpoints of side A, B and B, C. So when we will join the line PQ, the PQ will be parallel to the third side, means it will be parallel to AC again, and PQ will be half of the AC as well. Okay, because in triangle ABC, AC will be the third side, so PQ and AC will be parallel and PQ will be half of the side AC. That we will write down similarly here. So we will write down here similarly we can show that similarly we can show that PQ is parallel to AC and PQ is equal to half of AC. Okay, this I am giving as equation number 1 and this I am giving as equation number 2. Right? Now look at the equation 1 and 2 carefully. SR is parallel to AC and PQ is also parallel to AC. So we know that we know that if two sides are parallel to the same side or a common side, then they are parallel to each other. So PQ and SR will be also parallel, and similarly observe PQ and SR both are half of the AC. So PQ and SR both are the half of AC, means they are the half part of the AC, or you can say that in equation 1 and 2 the right hand side of both the equations are same. You can see half of AC is coming here also and half of AC is coming here also, means PQ and SR will be equal. So we can say that therefore by equation first and second, we can say that PQ and SR are parallel. PQ and SR will be parallel because they are parallel to the common side, and since they are the half part of the same side, they will be equal as well. So PQ is equal to SR. Here you can write down proved second part. Now see in the beginning what I have told you, how to prove a parallelogram. See, parallelogram we can prove by 3 different ways. Once again I repeat, listen it carefully. To prove any quadrilateral parallelogram, either you need to prove first part, the opposite sides are equal. Means you prove PQ is equal to SR and PS is equal to QR. Or you prove the opposite sides are parallel. Means you need to prove PQ is parallel to SR and PS is parallel to QR. And the third way is any one pair you select of opposite side. Any one pair of opposite side should be parallel as well as equal. So here either you need to prove PQ is parallel to SR and PQ is equal to SR. That is the one way. Or you can prove the another pair. PS is parallel to QR and PS is equal to QR. So you see first pair already we got PQ and SR we have proved parallel and PQ and SR we have proved equal to. We can check at last. See, PQ is parallel to SR and PQ is equal to SR. That we have proved. Any one pair of opposite side we have proved parallel as well as equal. So we can say that here PQRS is a parallelogram. We can say that since one pair of opposite side is equal and parallel. Okay, this complete the proof of the part number third as well. Here we'll write down proved third part. Okay, this complete the first question. Now I'm breaking the sequence and I'm taking the question number 6 over here. Okay, because question number 1 and question number 6 both are very similar. So you can also write down the solution of question number 6 first. Then you can continue as it is 2, 3, 4, 5 and then 7th question. Okay. So here see I am taking the question number 6 first. The reason behind that both the questions are 99% same. There is no difference. Only one small difference is there that we can do it easy. We can find out easily and we can solve it. Okay. So see what they are saying in the question number 6. Show that the line segment joining the midpoints of the opposite side of a quadrilateral bisect each other. Means what they are saying, we have given that one quadrilateral and we have given that the midpoints of the all the four sides. When you join all the four midpoints, then the diagonal, they are saying the joining the midpoints of the opposite side of a quadrilateral bisect each other. Show that the line segment joining the midpoints of the opposite side of a quadrilateral bisect each other. See, I will explain you in these things properly. Suppose if we have given that one quadrilateral, I am making a simple rectangle, but I will suppose as a quadrilateral. Okay, so this is my quadrilateral. Now I will take some midpoints over here and I will join it. So suppose if I am taking the midpoints, I am joining it. Once again, midpoints I have not marked. I will mark it later. Okay. Last one is remaining. Okay, so basically see what they are saying. We have given that one quadrilateral. So suppose if I take the name of this quadrilateral as A, B, C and D. Okay, this is my quadrilateral. Remember, it is not a rectangle, it is a quadrilateral. And I have marked their midpoint as P, Q, R, S. I have joined their all midpoints also. So new quadrilateral we got here, P, Q, R, S. Now what they are saying, show that the line segment joining the midpoints, means if you join their midpoints. So see, suppose if you join their midpoints SQ, okay, and if you join their midpoints, but we can take down, yes, okay. So if you join their midpoints, so see I have joined SQ over here. Similarly, if you join the midpoint PR, okay, so these line joining the midpoints bisect each other, means PR and QS will bisect each other. They will be bisecting the one line is bisecting the another one, means PR is bisecting SQ. So suppose if I say this is point O, okay, so we will get OS and OQ equal, and we will get same way PO and OR is also equal. That we need to prove here. You see, basically, how shall we prove it? First of all, what we will do, we shall prove PQRS is a parallelogram. Okay, since we have taken ABCD is a quadrilateral. Okay, so and PQRS are the midpoint. So as you can see in the first question, I have proved the same way, exactly in the same manner. See, I have proved PQRS is a parallelogram. Here also see the ABCD is given a quadrilateral. Only the shape of the ABCD they have taken a typical quadrilateral, and I have taken as a shape of rectangle. However, I am not supposing that is a rectangle. So first you see we have proved it a quadrilateral ABCD we have taken, and we have taken the midpoints of the sides AB, BC, and BC, CD, and DA. Okay, and we have proved PQRS is a parallelogram. So exactly same to same language you have to use it here, and you have to prove yes it is a parallelogram. Okay, you will prove it, means you need not to change any wording at all over there, and you have to prove that yes it is a parallelogram. Okay, that could be done. Now PQRS became parallelogram. For that you need to draw a line from A to C also. Okay, because without drawing a diagonal you will not be able to prove it. So suppose if I draw a line A to C, it may not pass through O. Okay, so I am little bit taking lesser than O. This will be a line. So this line can be drawn as a dotted one because it is a part of the construction. So here little bit I am going to rub over there. Okay, so this is a part of the construction. We'll mention it in the part of construction, and we'll say that the yes here, sorry, here I have by mistakenly I rubbed the PR. Let me do it once again. Okay, so we will say that here the line AC is a part of construction, and we shall prove it PQRS is a parallelogram. That 99% solution is same as it is. And now you are able to prove it PQRS is a parallelogram. There is no confusion, I suppose. Now if PQRS is a parallelogram, what exactly we need to prove? We need to prove here the diagonal of the PQRS. Now see, I will use the word diagonal, but actually what they are saying, the line joining the midpoints, means if you join one midpoint to another, so which midpoint you can join here, Q and S, the line joining the midpoints of the opposite side, line joining the midpoint of opposite side. So see, AB and CD are two opposite sides, so their midpoints are here Q and S. Okay, so if you join that line, become, sorry, that 2 points, so it will become a line QS. Similarly, if you join the midpoints P and R, it will become line PR. So PR will bisect QS and QS will bisect PR. That we need to show here. So in short, we need to show here OS is equal to OQ and OP is equal to OR. Clear? So how we can prove it? Now see, after proving a PQRS is a parallelogram, we can say that now we will have a diagonal PR and QS of a parallelogram. PR and QS are the diagonals of the parallelogram, and we know that in a parallelogram diagonal always bisect each other. So we can say that OS is equal to OQ and OP is equal to OR. Finish. Only one line we need to add here. In a parallelogram, diagonal bisect each other. So OP and OR are equal. OS and OQ are also equal. Then it will get over. So this question I am keeping you as a homework. However, I will provide you the solution of this question also. I will improve the figure if it is required. I will draw it once again and I will write down the whole solution as per the requirement. So you please copy the solution as it is, or you can write down, if better if you write down the solution by your own. Okay, so next time we shall see the question number 2 onwards.